Okay, so let's go through a quick example of how we can use probability and statistics to give us some understanding on the dependency of two different events or more, right? So let's assume that we have a test cell, right? You're an engineer, either a test cell engineer or maybe like a quality engineer who wants to increase the RFT, the right first time KPI, key performance metric, that is usually quantified in multiple companies or like in many companies. And you want to understand if the event of the first test to fail will affect the second one, right? What will be that relationship, or what will be that increasing probability or decreasing probability, right? So let's say that this is your test cell, okay? Let's say, just to keep it simple, that you have two different tests, okay? Let's assume that if it fails in the first one, we're gonna call that event A. And if the machine fails in the second one, we're gonna call it event B. So they're gonna test it. And if they fail in at least one or two, there is not gonna be an RFT, right? So we want to understand the relationship if event A is affecting event B, right? And we can use a very simple probability idea or probability principle on this, right? So we know that the probability of A event and B event to happen, right, if they're independent, is equal to probability of A times probability of B, right? And why is that, right? Because if they're independent, when A event happens, the probability of event B to happen doesn't change because they are independent from each other. But if they are dependent from each other, right, then when A happens, the probability of B to happen could change because they're dependent, right? So this will be the probability of B to happen if A happens, which either can be increased by a lot or decreased by a lot, right? We don't know, right? So we're gonna use this principle to test this out, right? Let's say that you took a sample of 100 machines that went through this test cell, right? And let's say that out of those 100, let's say 10 fail on A. Let's say that 8 fail on B. And let's say that when they both fail, let's say there were 5 of them. Okay? So having this information after you take the sample, right, we can test this out, right? So we know if they're independent, the probability of A and B to happen should be equal to the probability of A, right, which is 10, right, times the probability of B, right? And this should be equal to that. So that's 10% times 8%, that's 0.8%, I think. So 10 over 100 times 8 over 100. Yeah, so that's around 0.8%. Okay. Okay, so this is like the theoretical value in case they are independent from each other. But guess what? We also calculated the potential probability, right? So we know that probability of A and B based on our sample is equal to 5 over 100, which is equal to 5%. So this is telling us that the events are dependent on each other, right? We were expecting this probability and we got a much higher probability on the intersection, okay? Meaning that if A happens, the probability of B to happen increases by a lot, okay? So, and you can apply this if you have multiple tests as well. right? You can maybe even make like a chi-square, right? Or make like some real hypothesis testing to check the p-values or the probabilities that we're getting here, right? Just to have like some statistical confidence. But I think this is like a really good idea to understand of probability. This is called conditional probability. And if you want to test it out like in a longer perspective or like continuously updating probabilities, it will be the Bayes theorem, but it's the exact same principle. This is the main principle, right? So very important to understand, and it can be very useful to understand where you can improve.